In this video, I'll be going over the equation of a circle. So suppose we have a circle in the xy coordinate plane, and it has a center, let's call it h comma k. And we have a point, any point along the circle, we can give coordinates x comma y. So the distance from here, from the center to that coordinate, we call that the radius. So if we wanted to find the distance between the center and a point on the circle, we can use the distance formula. We'd say r squared is equal to the difference in the x coordinates, x minus h quantity squared, plus y minus k quantity squared, and then square root both sides. So we'd end up with square root of x minus h squared plus y minus k squared is equal to the radius. So either of these equations is appropriate. In practice, we usually use this first one more often. So what we have is r is the radius, and this is for a circle centered at hk. So that's the center of the circle. So what you might be asked is to come up with the equation of a circle or find the radius and the center of the circle given an equation. So let's look at an example of each of those. All right, first let's find the standard form of the equation of a circle with the center of 7 comma negative 3 that passes through the point 5 negative 2. So the equation of the circle, h minus, x minus h quantity squared plus y minus k quantity squared. That's what we want to deal with. So hk is the center, so hk, 7 and negative 3, are the coordinates of the center. So we can plug those in. So we'd say x minus 7 quantity squared plus y minus negative 3 quantity squared. So in order to find the standard form of the equation, we need to know what the radius is. We're not given the radius, but we do know a pass-through point for the circle, which is 5, negative 2. So let's just quickly sketch what's happening here. Probably should have done this at the beginning, but so 7, negative 3 is the center. So 7, negative 3. There's the center, and it passes through the point 5 comma negative 2. So maybe 5 is here, negative 2. So there's the point. So this circle does something like that, where it passes through that point 5, negative 2. All right, so we need to figure out what this distance is for the radius, and then we can plug it in right here. So because we have that pass-through point, we can plug in 5 for x and negative 2 for y. So we say r is equal to 5 minus 7 squared plus, for y we're going to say negative 2, minus negative 3 is plus 3 squared. So we end up with negative 2 squared, which is 4. Negative 2 plus 3 is 1 squared is 1. So square root of 5 is equal to the radius. Another way of saying this is r squared is equal to 5. So we could write this equation as 5 is equal to the square root of x minus 7 squared plus y minus negative 3, so y plus 3 squared. That's one way we can do it. Or if we use the other version, we could say 25 is equal to x minus 7 squared plus y plus 3 squared. And again, this is the more common way we would see this. And I realize I made a slight mistake here. So r squared is equal to 5. So this r squared should be 5 here. And in this instance, I should have square root of 5 there, because the radius is the square root of 5, not 5. All right, so I think we're cleared up there. And then let's kind of go in the other direction. Now we're going to be given an equation and we want to find the radius and the center. So for the radius and the center of the circle that has this equation, x squared plus y squared minus 6x plus 8y plus 10 equals 0. Now looking at this does not look anything like what we have in this standard form down here. So what we'll need to do is complete the square in order to get the equation into that standard form. And once it's in the standard form, we'll be able to identify the radius and the center. So to complete the square, we want to group the x terms together and the y terms together. And I'm going to move this 10 to the right-hand side of the equation. And I'm leaving a space after each of the x and y terms. So to complete the square, what we want to do is we look at the b term here, -6, and we say what's half of -6, and then square that value. So half of -6 is -3, -3 squared is 9, but I'm just going to write it like that for now. And then for the y terms, I say half of that b term, which is 8. Half of 8 is 4. 4 squared is 16. Okay, so what I've done is what we have is x squared minus 6x plus 9 plus y squared plus 8y plus 16. Okay, so what we see is that I've actually added 9 and 16 to the left-hand side of the equation. So on the right-hand side, I need to also add those values in order to keep the equation balanced. All right, now the whole reason we want to complete the square is because each of these groups of terms is going to factor into something that, or two factors that are the exact same. So x squared minus 6x plus 9 factors to x minus 3 times x minus 3. The y portion factors to y plus 4, y plus 4. And so we can rewrite this as binomials getting squared. And then on the right-hand side, we have -10 plus 9 is -1, plus 16 is 15 here. So that's the standard form of the equation that we want. So once we have that standard form, it's going to be easy to find the center and the radius. So the center is going to be 3 comma -4. And the radius is going to be the square root of this, because this is equal to r squared. So r is going to be square root of 15.